Okay, so let's start. So today we are going to discuss a very important topic in mathematics and in calculus, that is continuity and differentiability of some special functions. So first of all, I will write the special function like greatest integer function, fractional function, modulus function, and the last one is Signum function. So we can see that all these four functions are very important in the calculus, and we are going to discuss continuity and differentiability of all these functions. So we will start with greatest integer function, where we will discuss first continuity, then we will discuss differentiability of the greatest integer function. So first we will see the greatest integer function. What is the definition of greatest integer function? So first function is greatest integer, also named as GIF function. So fx equals to greatest integer x. So this close bracket is the symbol of greatest integer function. So clearly, if we see the graph of greatest integer function, then we can see that this is stepwise, like from 0 to 1. At 0 it is 0, at 1 here is missing, then this one 1, 2, like this one. So this is 1, 2, 3 and 4, and here we can see that this is 1, 2 and 3, this is -1, this is -2, -1, -2. So if we see the graph of greatest integer function, then clearly we can see that the function is not continuous at integers point. If we see at x equal to 1, if we see x equal to 1, if we approaching x equal to 1 from left side, then we can see that we are going to 0. But if we are approaching point x equal to 1 from right, then we can see that we are going to 1. So clearly at x equal to 1, you can see that LHL is 0 and RHL is +1. This means the left hand limit and right hand limit is not equal. That's why function is not continuous at x equal to 1. Similarly, you can see that point at x equal to 2. At x equal to 2, if we are approaching the point 2 from left, then we can see that left hand limit is 1. But if we are approaching the point 2 from right, then we can see that it is 2. So for point x equal to 2, left hand limit is 1 and right hand limit is 2. That means not continuous because limit does not exist. Also we can see that if we have any integer point x equal to a and we want to discuss the continuity of greatest integer function at x equal to a, then we will find left hand limit as well as right limit at x equal to a. So LHL is limit h goes to 0 and that will be a minus h, right? And our RHL is a plus h. So here if we are subtracting some small values from a, then you can see that, like suppose you have a value of a is 2 and you are subtracting 0.1 from 2, then it will be 1.90, right? Then you can see that the greatest integer of 1.9 is like 1. So that will be 1 less from a, that is a minus 1. And if we are adding some small, very small quantity in an integer, then the greatest integer will give the same integer, that will be a. Because suppose if we are adding 2 plus h, then this is something 2 point like 0, 0, 1, then the greatest integer will give 2. So if we are adding very small value, then that does not affect the value of integer and that will give the same. Now you can see that both are different, not equal. So at x equal to a, this function is not continuous. Clearly we can see that at x equal to a, this function is not continuous. Hence we can see that greatest integer x is never continuous at integers point, and at fraction point and except integers we can see that it is continuous everywhere, but only on integer it is not continuous. Okay, so now we will discuss some more questions on greatest integer x, where we have to check the continuity of greatest integer function. Like you can see that here only x, but if you have given some function in the close bracket, then you can check the continuity of that greatest integer function. Suppose taking an example number 1. Suppose we have a function like fx equal to greatest integer log ex. Now we want to find the points where this function is not continuous. Okay, log ex is a function which is under the greatest integer. Now we know that if this quantity which is under this close bracket is integer, then that function will be discontinuous. Means whenever log ex gives an integer, the function will be discontinuous. So we can write that log ex integer, this will imply discontinuous, right? This will imply that function will be discontinuous. So now for simplicity, suppose log ex is any integer, that is k. That is k. So clearly from property of log, x will be e to the power k. So whenever we have a value like e to the power k, that function will be discontinuous at that point. For example, if we take k equal to 0, then it will give e to the power 0, that is 1. If we take k equal to 1, this will give e to the power 1, that is e. Then e square, e cube, e4, e to the power minus 1, e to the power minus 2. At all these points, this function will be discontinuous. So it is very simple, very evident that you can see that whenever this function is integer, you have to find the value of x, and at that points the function will be completely discontinuous. So now move to the next example. We will see another example where we will see the continuity of greatest integer function. Okay. So suppose our function is fx equal to greatest integer sine inverse x. So now we have a function greatest integer sine inverse x. Now we have to check the continuity of this function, where this function is discontinuous. So I have already told you that this function is discontinuous whenever sine inverse x is integer. So whenever it is integer, sine inverse x is integer, then function will be discontinuous. Now we know about sine inverse x. This is an inverse trigonometric function, and sine inverse x, the graph of sine inverse x is like, this is pi by 2, this will be minus pi by 2, and graph will be like this one. So this is plus 1, this is minus 1. So domain of the sine inverse x is minus 1 to 1, and range of sine inverse x is minus pi by 2 to pi by 2. Now we know that between minus pi by 2 to pi by 2 there are 3 integers. Which one? Minus 1, 0 and 1. So these integers are the integers which are between minus pi by 2 to pi by 2. So sine inverse x can take integers value that will be minus 1, 0 and 1. So we will see the cases when sine inverse x equal to minus 1, then x will be minus sine 1. Again, when we will take sine inverse x equal to 0, then x equal to 0. And last one, whenever sine inverse will take 1, then x will be sine 1. That means this function is discontinuous at 3 points, and those points are x equal to 0, sine 1 and minus sine 1. So at these 3 points you can see that this function is not continuous. So okay, so now we will see next question, that is, so our question is fx equals to, so now we will discuss the discontinuity of this function, okay, where this function is continuous or where this function is discontinuous. Again, this is a greatest integer function, so we will see whenever 2 upon 1 plus x square is integer, then this function will be discontinuous. So 2 upon 1 plus x square will be integer. Whenever this is integer, then this function fx will be discontinuous. Okay, so let's see when 2 upon 1 plus x square is integer. So if we see that x equal to 0, put x equal to 0, this will imply 2 upon 1 plus 0 equal to 2, and this is integer, right? Again, put x equal to 1. If we put x equal to 1, then 2 upon 1 plus 1 square equal to 1. Again, this is integer. After that, whatever we will put the value of x, then that will be a fraction value, okay? So now we can find integer value whenever we will put x equal to 0 and x equal to 1. So there are 2 points of discontinuity, that is x equal to 0 and 1. So at x equal to 0 and 1, this function will be discontinuous, okay? And apart from this 0 and 1, you can see that this function is continuous at every point whenever x is greater than or equal to 0, okay? So this will be this was the third example. Now we will see another example which is related to the trigonometry, and one more example where we will count the number of point of discontinuity, okay? So next question is, I think this will be the fourth example. So suppose हमारे पास function, suppose we have function let fx equal to greatest integer x by 3, where x belongs to 0 to 30. Find number of points of discontinuity. So here we have given a function. So we have given a function that is greatest integer x by 3 and x belongs to 0 to 30. We have to check where the function is discontinuous, and after all we will discuss the number of points of discontinuity. So whenever x by 3 is integer, this function will be discontinuous, right? This is the definition of continuity of the function. Now we can see that whenever we will take x as a multiple of 3, then this will give integer. Suppose we will take x equal to 3, then it will be integer. Suppose we are taking x equal to 6, then 6 by 3 is integer. So whenever we will take the value of x as multiple of 3, then it will give the integer. So x equal to, we will start with 0 because 0 by 3 is 0 and it is integer. So 0, 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. So at these points you can see that x by 3 is always integer. That means these are the points of discontinuity of this function. So we can count the points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. At 11 points, we can see that this function is discontinuous. Okay. So now we will see a trigonometric example where we will discuss the discontinuity and continuity of trigonometric function within greatest integer. So next question is question number 5, that is fx equals to 2 cos x within greatest integer bracket, x belongs to 0 to 2 pi. So now here we have two ways. One is by graph, that we will draw the graph of 2 cos x and we can see the discontinuity. And another thing is by critically thinking, we can see the we can find the point of discontinuity. Okay, we want to find here the number of point of discontinuity. So first we will see the graph. So the graph of 2 cos x is like this one. Okay, and we have to find the discontinuity on this interval 0 to 2 pi. So this is 2 pi, this is 0, this is plus 2 and this is minus 2. So this graph is here, and this is 1, okay, and this is minus 1, again this is minus 1, this is minus 2, again this is 1 and this is 2. So if you draw the graph, then we can find easily, but we have to draw whole graph. Okay, now we will find the point of discontinuity with the help of our concept. So our concept is whenever 2 cos x is integer, whenever 2 cos x is integer, then function is discontinuous. Okay, but there are some points we have to note that for this concept here. Okay, because this is a periodic function, so you have to see that. So now 2 cos x, okay, so 2 cos x, we can see that whenever put x equal to 0, then it will give 2. So for x equal to 0, it will give 2 cos x will be 2 because it is integer, right? At x equal to 0, cos 0 is 1, 2 1 = 1, 2. So here we can also write only 2 cos x. When x equal to 0, then 2 cos x equal to 2, right? Now at x equal to pi by 3, we know the value of cos x. Whenever we will put the value of x equal to pi by 3, then this function will give 1 by 2 into 2, that is 1, and again 1 is an integer. So at x equal to pi by 3, 2 cos x equal to 1, we can see the graph here at pi by 3, this will give 1. Okay, so at x equal to pi by 3 also this is discontinuous. Now next point is pi by 2. So if we put x equal to pi by 2, you can see that this is integer because cos pi by 2 is 0 and 0 into 2 is 0. Again at x equal to pi by 2, 2 cos x equal to 0 means integer. Hence this function is discontinuous at x equal to pi by 2, right? After pi by 2, we can go in second quadrant. We can see pi minus pi by 3, that is 2 pi by 3. This is 2 pi by 3. Okay, so at 2 pi by 3, this will give minus 1. You can see that at 2 pi by 3, cos 2 pi by 3 is minus 1 by 2 and multiply by 2, that will give minus 1. So again at x equal to 2 pi by 3, 2 cos x gives minus 1, that is integer. So also at the point x equal to 2 pi by 3, this function will be discontinuous. Now after 2 pi by 3, we have a point that is pi. Now at pi, we can see that from 2 pi by 3, this pi, this is 4 pi by 3. You can see that at pi this function is continuous, greatest integer, because if we draw two greatest integer functions graph here between 2 pi by 2 to 4 pi by 3, then you can see that between 2 pi by 3 to 4 pi by 3 graph is lying between -1 to -2. Then graph will be like this one, okay, this one. So you can see that at pi graph is continuous. So also we can see that at pi this will give integer, but at pi this is not discontinuous, this is continuous, because we can see that from 2 pi by 2 4 pi by 3 this graph is like at -2, and this is a straight line that is continuous. So at x equal to pi this is continuous. Now move to the 4 pi by 3. So whenever x equal to 4 pi by 3, again it will give -1. 2 cos x equal to -1, hence discontinuous. After 4 pi by 3 we will reach 3 pi by 2, and x equal to 3 pi by 2, cos is 0, hence 2 cos x is also 0. That means this function is discontinuous at x equal to 3 pi by 2. After 3 pi by 2 we will reach here in fourth quadrant, and this is 2 pi minus pi by 3. 2 pi minus pi by 3, that is 5, 3 to the 6, 5 pi by 3. This is 5 pi by 3. So at x equal to 5 pi by 3, again cos x is 1. You can see that 1. So that will be, this function will be 2 cos x will be 2. At x equal to 5 pi by 3, this will give 2 cos x equal to 1. Hence discontinuous at x equal to 5 pi by 3. And finally we will see the 2 pi. At x equal to 2 pi, 2 cos x will be again 2, that is integer. So at all these points, this function 2 cos x will give the integer value, hence discontinuous. So we will count how many points are here where this function is discontinuous. X equal to 0, 8, 1, 2, 3, 4, 5, 6, 7 and 8. So here we have 8 points where this function is discontinuous, okay. Also we can draw the graph of the greatest integer, and we can see that this graph is discontinuous at 8 points, that is 0 pi by 3, pi by 2, 2 pi, 2 pi by 3, 4 pi by 3, 3 pi by 2 and last 5 pi by 3, okay. So 8 points are here where this function is discontinuous. We have to be very careful on pi, because on pi this function is continuous. Now move to the next question, and this is the last question for greatest integer topic. Given function fx equals to greatest integer x minus 2 cube upon a sine x minus 2 plus a cos x minus 2 is continuous on 4 to 6, then find value of a. So this is a good question where we will see another concept, that how this function is continuous although this function involves greatest integer, okay. So now this function involves greatest integer, but this is continuous on 4 to 6. So we have to see that what is the value of required value of a. We have to put here that this function is continuous, okay. Now see the function very carefully. Here we can see 3 functions. One is greatest integer function, another is trigonometric sin x function, and another is cos x function. We already know that cos x and sin x are continuous function on whole real line. So this function is continuous. This function is continuous. Now the only problem with us is greatest integer function. So we know that greatest integer function is not continuous at integers, right? So we have to choose the value of a in a way that this is 0. Whenever this will become 0, then only left function will be a cos x minus 2 and that will be continuous, right? So here we have to see that when x minus 2 cube upon a is 0, not 0, that will be between 0 to 1, then greatest integer of a number which is between 0 to 1, that will be 0, right? So we need to focus on x minus 2 cube upon a. Whenever this value will be between 0 to 1, then greatest integer of this is 0 and hence function becomes continuous, right? So now we can see that x belongs to 4 to 6, okay? So x minus 2 belongs to 2 to 4, x minus 2 cube belongs to 8 to 64. So now we can see that x minus 2 cube is between 8 to 64. Now we want that this expression will be between 0 to 1, right? And we know that the value of any fraction will be between 0 to 1 whenever denominator is greater than numerator, right? So if we take value of a greater than 64, because we know that maximum value of x minus 2 cube is 64. So if we take value of a is greater than 64, then we can see that this value will be between 0 to 1 and hence greatest integer of this function will be 0 and hence the whole function will be continuous. So we have to just choose a is greater than 64. This is our answer. So if we will take a greater than 64, then this will become 0 and hence the only left function will be a cos x minus 2 and that will be continuous, okay? So our answer is a must be greater than 64. So this was the last question on greatest integer topic. Now we will move to the next topic, that is fractional x, okay? So next one is fractional x, okay? In this video we are discussing about continuity. After discussing continuity of fractional, signum and mod, we will discuss differentiability of these functions, okay? So now move to the fractional x. So fractional function, as we know, fx equal to fractional x, okay? This is defined as x minus greatest integer x, okay? This is defined as x minus greatest integer x. So clearly you can see that x is a polynomial, simple 1 degree polynomial, linear, and this is greatest integer x. So whenever you will take integer, then this will be continuous because it is polynomial function, linear function, but this is not continuous. So we can see that at integer points x is continuous, but this one is discontinuous, okay? So whenever you can see that whenever x is integer, this will be continuous, but this is not. Hence the whole function will be discontinuous whenever x is integer. So here we got a result that whenever this x is integer, then the fractional function will be discontinuous. We can see the graph. If you see the graph, okay, so for fractional the range is 0 to 1, less than 1. So this is like this one, this one, this one, this one, this one. So you can see that, and also we can draw the graph in left side. So you can see that at x equal to 1, this is x equal to 2, this is x equal to 3. So at every integer point, this fractional x is discontinuous. So this is very same as greatest integer function, whenever x is integer, then that function will not be discontinuous, function will not be continuous. So this is the same theory for greatest integer function. Okay, now our third function is continuous function, that is modulus function. So third function is modulus function. So first we will see what is modulus function. This is defined as mod x, that is whenever the value of x is greater than or equal to 0, this is x, and x is less than or equal to 0 minus x, and we know the what is the graph of okay. So modulus function is defined as whenever we will take the non-negative value, then it will give simply x, and if we will take negative value, then it will give minus x. You can see clearly that this graph is continuous everywhere, because you can draw the graph without lifting the pen. See this one like this. So you can see that modulus function is always continuous. Modulus function is always continuous. Okay, so mod x is always continuous. Now we will see that whenever we have a function like this one, y equal to mod of fx. So see, modulus function does not affect the continuity. If your function is continuous, then mod fx is also continuous. But if we have discontinuities for fx, then you have to check that. Okay, but if we are sure that fx is continuous everywhere, like, then mod fx will also be continuous at everywhere. Okay, because modulus function is doing only one work, that is it is making the function's value positive. Okay, so if your function is continuous, if fx is continuous, this will imply mod fx is continuous. Okay, so for example, if you are taking function like mod x minus 1 mod, this is continuous. Mod x minus 2, this is continuous. Everywhere this will be continuous. Mod sin x, so we know that sin x is a continuous function, hence mod sin x is also continuous at everywhere, at every real point. Okay, so this will also be continuous. Mod cos x, this will also be continuous. Okay, so modulus function does not affect the continuity of any function. Okay, so clearly we can see also the graph by the graph. Now move to the next function, that is Signum function. That is very important function for continuity and differentiability. So the last function is Signum function, where we will discuss the continuity of Signum function, and in next video we will discuss differentiability of all these four functions. Okay, so move to the next topic, that is Signum function. Okay, so what is Signum function? So first we will define y equals to Signum x, and it is defined as whenever we will input the positive x, then it will give 1. When we put x equal to 0, it will give 0, and when we input the x less than 0, then it will be minus 1. So the graph of Signum x is very easy. You can draw this. So when x is greater than 0, like this one, this is plus 1, and here x equal to 0, the function of value is 0, and this is minus 1. Okay, so this is the graph of Signum function. Now we can see that this function is discontinuous at x equal to 0. How? At x equal to 0, this is discontinuous. How? If we are approaching x equal to 0 from left, then we are reaching at y equal to minus 1. So left hand limit is LHL is minus 1. Okay, we are talking about at x equal to 0. And if we are approaching x equal to 0 from right, then you can see that we are reaching at a point where y equals to 1. The value of function is 1. So RHL is plus 1, and as LHL and RHL are not equal, you can say that this function is not continuous at x equal to 0. So we have to be very careful about Signum function in the input, that is x. Whenever this x is 0, this function will not be continuous. For example, if we have any function like Signum of fx, suppose we have a function Signum of fx and we want to check the continuity of this function, then simply you have to take only one step, that is check when fx is 0. Whenever this fx is 0, this function will be discontinuous. Okay, it should be very sure that whenever this input is 0, then this function will be discontinuous, because we already discussed that at x equal to 0, when this input is 0, the function is discontinuous. That means whenever fx is 0, this function is discontinuous. So we will take some examples to see how we will describe or define the continuity of Signum function. Okay, see, suppose we have a function like fx equal to Signum x cube minus x. Suppose this is, we have function and we want to discuss the discontinuity or continuity of this function. Okay, so whatever we will do, x cube minus x equal to 0. Okay, so we will get x common here, x square minus 1 equal to 0. The factors of x square minus 1 is x minus 1 and x plus 1. So here we can found 0, 1 and minus 1. So this function is fx is discontinuous at x equal to 0, 1 and minus 1. So you can clearly see this, that at these 3 points this function is discontinuous. Okay, now move to the second question. So second question is like, suppose we have a function Signum, we can take like 2 cos x minus 1. We want to discuss the continuity of this function. Okay, so whenever 2 cos x minus 1 is 0, this function will be discontinuous. Okay, so we will see that whenever 2 cos x minus 1 is 0, this function will be discontinuous. So now here cos x equal to 1 by 2, and this will be the general solution of this equation. So this is of the form cos x equals to cos alpha, where the solution is x equal to 2n pi plus minus alpha, n is your integer. Okay, so here we know the value of cos pi by 3 is 1 by 2. So this equation will become of the form cos x equal to cos alpha. So x will be 2n pi plus minus pi by 3. So at x equal to 2n pi plus pi by 3, this function is not continuous. So for every time if you have Signum function, then you have to just equate the 0 and you can find the discontinuity of that given function. Okay, now move to the third problem. These are 2 problems where you can understand the continuity and discontinuity of the Signum function. Okay, now move to the next question. So suppose we have a question like fx equals to Signum x square plus 2x plus 3. Okay, so we have a function Signum x square plus 2x plus 3, and we want to discuss the continuity of this given function. So now script is, you can see that x square plus 2x plus 3 equals to 0. This will be 0. Now we want to find the value of x for this, but you can see that this is a quadratic expression, and if you will find the discriminant of this quadratic, then d equals to b square minus 4ac, and that will be 4 minus 4 into 1 into 3, and that is 4 minus 12, that is minus 8, that is less than 0. So d is less than 0. So we know if d is less than 0, then the graph will be, here a is positive, so the graph will be like this one. That is, this graph does graph of x square plus 2x plus 3 never touch the x-axis or cut the x-axis. The graph will be always above the x-axis. Hence we can see that the x square plus 2x plus 3 will be always greater than 0. Always greater than 0. So that means we are putting input always greater than 0, and we know the signum function gives 1 when we put the positive value. We are putting here positive value, hence this will be 1. So this is a constant function, fx equal to 1. This is a constant function, fx equal to 1, and hence always continuous. Continuous on R. This function is always continuous because we checked that this is always greater than 0, and hence we can clearly see that the function value will be 1, and the fx equal to 1 is a constant function, hence continuous for all the real numbers. Okay. So we discussed about continuity of greatest integer function, signum function, modulus function, and fractional function. Okay. In next video, we will discuss about differentiability of all these four. Okay. Differentiability, and also we will discuss the definition of what is differentiability and everything. Okay. So now we will stop here and see you in the next video.